Hi, and welcome to this video on balance methods, with a focus on the so-called capture point method. We will start off with the reason why balance methods are useful, and we will then look at different balance methods that have been researched by Project March. Afterwards, we will go a bit more in depth about Project March's preferred balance method, capture point. If you look at it bluntly, walking is simply the act of constantly falling forward and then catching yourself by putting your foot in front of you. Your body knows exactly when you're falling, which direction you're falling, and how to prevent itself from actually falling on the ground. All thanks to your balance organ, your reflexes, and your years of experience with this process. The center of mass is very important to stay balanced. If it is roughly located somewhere along a vertical line in between your feet, then you won't fall over. When taking a step, your center of mass moves forward. Subsequently, your body takes a step to place the center of mass between your feet again. You can see this happening here. Now, an exoskeleton doesn't have a combination of the techniques mentioned earlier. Therefore, it depends on its user to stay balanced, for example by using crutches. However, this is very tiring for the user. And exoskeleton balance is therefore a hot topic in the exoskeleton technology. At Project March, this is no different. For multiple years, several team members have dedicated their time to develop a way to balance the March exoskeleton. The fifth team of Project March has done research into multiple balance methods, such as zero moment point, virtual pivot point, and capture point. Eventually, it was decided that for Project March, the capture point method seemed like the best balancing method. This decision was based on the conclusion that capture point is the best method for walking gaits and because it is relatively easy to create a proof of concept for this method. Before we can talk more about capture point, we should first look at the capture region. I said before that when you're walking and you take a step, you're actually falling forward. If this is the point where your support foot is, and this is the area where you can place your other foot, then the capture region is the area on the ground where you can place your foot to regain your balance. The size and position of this area are dependent on your center of mass and your walking speed. The capture point itself actually lies within this capture region, and is the point in this region where you should place your foot to come to a standstill. Ideally, the exoskeleton is able to calculate the capture region and capture point by itself, using the center of mass from earlier, so that it can balance itself. Now, since you're walking, you obviously don't want to stand still after one step. This means that the exoskeleton should decide to place its foot not exactly on the capture point, but slightly behind it. This allows the exoskeleton to maintain some momentum and thus keep on walking. If the exoskeleton can then continuously calculate the point where it should place its foot, you've got yourself a self-balancing gait. In reality, this is more difficult than it seems, for multiple reasons. For example, the sudden movements of the user, such as swinging an arm, make it very difficult to accurately calculate capture point over a longer period of time. This makes it harder to calculate the right place to step. Additionally, even after calculating the right point to place your foot, it remains a question what kind of gait can best get you to that point. This last issue is something that we will touch upon in the next exercise.